and welcome to Unit 3, Module 10. We're going to talk about the nervous system and the endocrine system today. So here are your learning objectives. Pause it if you want to review what you should know by the end of this video or have learned by the end of this video. And then here are your vocab. So a little bit better than Mod 9, right? So let's get right to it. So the nervous system. So when we think about those neural networks that we were talking about last module, you want to think of this as your body's fast electrochemical way of communicating with each other. So there are two parts to this neural network, this nervous system. There is the central nervous system, also known as the CNS, easier to say, and that is made up of your brain and your spinal cord. That's it. Brain, spinal cord, central. And then there is the peripheral nervous system, or the PNS, and that's everything else, the rest of the nervous system. So if you think of the word peripheral as like the outer aspect of whatever you're talking about, right? Like your fingertips and your toes, like that would be your peripheral parts of your body, for example. That's what we want to think of when we think of peripheral. So here's an example. So on the left, central nervous system, there's your brain, your spinal cord, and on the right, your PNS is everything else, all the rest of our nerves. So when we're talking about how they communicate with each other, there are different types of nerves. There are 3 different types that you need to know for this class. So let's take an example of touching something hot, like a candle. So first thing, your sensory nerves would get this, or your sensory neurons would get this, and they would carry that info from your fingertips towards your central nervous system. And at that point, before it even gets to your brain in this case, because it's more of a reflex type thing, your interneurons in your spinal cord get that message, and they send the message back out of your brain to the motor neurons. And the motor neurons tell you to move your hand away. So you have done this before you've really become aware of what's happening. Like your hand just jerks away, and it's like at the same time your brain is like, oh, that was hot. So here's just kind of a diagram of the 2 different main parts, the central nervous system and the peripheral nervous system. So again, central nervous system, central, think brain, spinal cord, and then peripheral is everything else. That's goal is to carry the messages back to the central nervous system, because that's the brains of this whole system, right? Literally. So the peripheral is broken up to a couple parts. So the 2 main parts of the peripheral system are the somatic nervous system and the autonomic. So autonomic, think of the word automatic. So this is our body's automatic operating system. These things happen without us thinking about it, like breathing, for example, and heart rate and all that. We can bring those things into conscious awareness, but they also happen without us thinking about it. And then we have voluntary movements, like, for example, walking. So that would be somatic. So the autonomic breaks down into 2 other parts. So those automatic things are 2 different parts. There is the sympathetic and the parasympathetic. So this is our fight or flight mode. So when the sympathetic kicks in, we are stressed. Our heart is pumping. We're starting to sweat. Our digestive tract is kind of slowing down to reserve energy for all the rest of the body. And we are in that fight or flight mode. And then once that kicks in, our parasympathetic is trying to kick in to calm us down and bring us back down. So those are the 2 parts of the autonomic. So those are just the definitions written out for you. I've already gone over this, so I'm not going to spend a lot of time on this slide, but feel free to pause it and write down these definitions. Okay, so a little trick for remembering those two parts of the autonomic nervous system is to remember S for sympathetic, S is for stress, and P for parasympathetic, P is for peace. So I really like this. I find it super helpful. It's like one word. P is for peace, really. Even if you remember one of them, right? Then you remember the opposite. So this is just another breakdown to show you. I know this looks intimidating, but I just wanted to show you how one thing would work in this as an example. So they have the somatic nervous system here, and acetylcholine, remember that neurotransmitter that's responsible for muscle movement, and somatic is voluntary. So this is our central nervous system sending a message to our peripheral nervous system, and the message is acetylcholine. It's about movement, so our skeletal muscles will be moved in this whole operation. In the autonomic, again, see it's divided into sympathetic and parasympathetic, and acetylcholine is being used in the sympathetic because we're getting norepinephrines going, like we're stressed, and then in parasympathetic, we're trying to relax and calm down. Peace. Okay, so the central nervous system. So when you think about this, think about all those little neural networks. And I'm sure you've heard the expression about use it or lose it. And that's really true for neural networks. So the more we use a certain neural pathway, the stronger it gets. And when we were talking about the parts of a neuron in the last module, we talked about the dendrites, the receiving messages part of the neuron. So the more dendrites that a neuron has, the more neurons it can interconnect with. So just to give you some idea about what we're talking about here, the central nervous system has 400 trillion synapses. That's so cool. And a grain-sized speck of brain contains 100,000 neurons and 1 billion synapses. That's incredible to me. Like, I can't even, that's just amazing right now. So cool. So our spinal cord, this is kind of review from what I just mentioned, but the spinal cord, that's where all our reflexes happen. It's kind of like those interneurons in the spinal cord act as their own little brain. And without even asking the permission of the brain, which usually the whole rest of our body has to do, the spinal cord and those interneurons just react with those reflexes. So this top picture is the one you've already seen, and the bottom picture is a picture of the doctor doing that check for your reflexes. So they're actually checking your all your neurons, right, to see if they're functioning properly, if your central nervous system is functioning properly. So the other system that we needed to talk about in this module is the endocrine system. So the endocrine system is our slower system. So if you think of, and let me just show you, I had this picture and I didn't even forgot to talk about it. If you think of our nervous system as that fast message, so that's like a text message, it's like instant, right? The endocrine system is more like Amazon. Like, it's not super slow, it's gonna get there, and it could get there same day, right? So it's gonna take longer, but also because it takes longer, because it's secreting hormones into our bloodstream, it also takes longer to leave the system. So whereas the parasympathetic and the sympathetic can kick in super, super fast and be gone super fast, hormones stay with us a little bit longer. So the endocrine system is our body's slow chemical communication system with a set of glands that secrete hormones into the bloodstream. So what are hormones? Hormones are chemical messengers that are manufactured by the endocrine gland. So it's made up of a bunch of endocrine glands. Honestly, you really don't have to know a lot of detail about all of them. I'm going to go over what you should know. So these do a whole bunch of different things. They regulate our energy levels, our metabolism, our sleep, growth, reproduction, water, so basic homeostasis like water, nutrients, electrolytes, all that good stuff. And so 2 that you really should know because they're important for what we've been talking about are the adrenal glands. So those are located just above the kidneys, and they are the ones that secrete the epinephrine and norepinephrine that we use in that time of fight or flight. So when our body is reacting in that fight or flight mode, it tells the endocrine system to kick in and the adrenal glands to release that. So when that is being released, that kind of might stay with our system a little bit longer. So the most important gland to know, because it is the master gland, is the pituitary gland. This is the body's most influential gland. It controls all the other glands, and it regulates growth. So if you think a student of many years ago, he thought of the pituitary gland as a pit, like an armpit, and that helped him remember growth because it's responsible for a growth hormone, and armpits get smelly and hairy in puberty, and so that helped him remember that. Maybe that works for you, maybe it doesn't. Thought I'd throw it out there. Maybe I grossed you out. Sorry, not sorry. It happens. So the pituitary gland tells all the other glands what to do. However, the pituitary gland does have a boss. The boss of the pituitary gland is the hypothalamus, which is a part of the brain. And we will be talking about the hypothalamus in the next 2 modules when we talk about the different parts of the brain. So here's a picture of the endocrine system and all of the glands. So again, the key ones that you need to know for this class that you'll be really asked about are the pituitary gland, and see how it's located in the brain, right? So the hypothalamus in the brain can speak to it easily and communicate. And the adrenal glands are right there above the kidneys. So those are the ones you should know. Why is this not changing? There we go. All right, so here's the system that I was talking about. So the hypothalamus tells the pituitary gland what to, I know this seems confusing, but all I really want you to get from this is that the hypothalamus is getting some sort of message from the brain. So maybe some sort of sensory message or some sort of message from the brain. And the hypothalamus tells the pituitary, hey, we need to do this. The endocrine system needs to do this. And the pituitary gland is like the supervisor. And he's like, okay, like adrenal glands, you need to get going. I'm going to get some growth hormone, blah, 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 right? So he controls everyone else. So again, here's the same little close-up of where the pituitary gland is, and then right there above it is the hypothalamus. And here's the nice little chart that compares the two. I've already talked about this stuff, so feel free to pause it and review the similarities and differences between the two. All right, so that's it. So our key takeaways. So the nervous system is broken up into 2 main parts, the central nervous system and the peripheral nervous system. The peripheral nervous system is broken up into 2 main parts, the somatic and the autonomic. The autonomic is broken up into 2 parts. Getting the theme? The sympathetic and the parasympathetic. And then we have the endocrine system, and the endocrine system works slower than the nervous system, more like the mail, and the nervous system is more like a text message. But the endocrine system lasts longer because it goes slower. And then the pituitary gland rules them all. So that's about it. And then who rules the pituitary gland, actually? Hypothalamus. So that's about it. Wraps it up, and I will see you in class.